Hello YouTube, this is Jeff Marcic and welcome back to Universe Sandbox 2! So, today we are going to be experimenting with collisions, but not just with any kind of collisions. We are going to be testing out collisions with our beautiful home Earth. So, to start off, we are going to experiment with different sizes of asteroids. Because, that's one of the things that we believe cause some extinctions. So, random asteroid, we're just going to shoot at Earth, but we're going to start with different sizes. So, the first one we're going to do is an asteroid that could collide with Earth in the future. And this asteroid, we're going to call it Asteroid 1. And the size of this one is 1 kilometer wide. Now, you may say, well, 1 kilometer? What's that going to do to Earth? Well, you'll see in a bit. Now this is cool, you can actually see it turning as well. So I'm going to actually slow this down because I want you to see. So even though it's 1 kilometer and Earth is over 6,000 kilometers, it does something. Just slow this down because I want you guys to see like what happens once this thing actually collides with Earth. And slow down so you can see the effects of it colliding. It hasn't reached the atmosphere yet, but it's about to do that. So you're going to see it collide. There should be like a small shadow on the Earth where it's going to collide. And it's going to go boom. It's going to hit boom. Now look at that shockwave. Look at that shockwave. And there's some fragments there. But look at that shockwave. Of course, the temperature didn't change at all. But you can see the shockwave is big. And unfortunately, I die early because right there, there's so many fragments coming back to Earth, and there's the shockwaves from the fragments. But look how big that main shockwave was. That was a big shockwave. Now these are smaller ones, of course. Of course, that was just 1 kilometer away. That barely did anything. Sorry if you guys heard that. Anyways, let's speed up time so this doesn't take forever. And that's just gonna cool down. And now there's just craters there of what used to be water. Yeah, look at that. Oh my god, South America, look at that. Alright. So that's just 1 kilometer wide. That didn't do much. Now we're going to experiment with an asteroid that we think what caused the dinosaurs to be extinct. And this asteroid, we think, was 6 kilometers wide. So, we're going to name this Asteroid 2, and this is going to be 6 kilometers across. So, this will do something as well, but it may not seem like it, but it does do something. Now, what's so cool is that you can see Earth rotating while it's approaching it. I find that pretty cool. I don't know, but I just find it cool. It's going to collide with the Atlantic Ocean again, unless Earth turns fast enough, which I don't think it will. And slow it down. Okay. Because even though it's 6 kilometers wider than Earth again, so Earth is more than like 1,000 times larger than it, this still does something. You guys are going to see the shockwave. Alright? And boom! Look at that shockwave. That was 6 kilometers wide. And once again, the temperature didn't change at all, but the shockwave it creates is pretty big, don't you guys think? And there's shockwaves from the returning, but that was big. That was a big shockwave there from the main thing, and now there's of course the fragments falling back down to Earth, and we got more craters now. So I'm gonna let those cool down, and then we're gonna see what the more craters created. Look at that. That doesn't sound look pretty at all. So, now we're gonna have some fun with this. We are now going to launch an asteroid that is 25 kilometers across. Yes. Now again, you might think that it will do nothing because Earth again is over 6,000 kilometers across. But this does do something. It may not seem like it, but it does do something. I think that's too fast. Is it? No, it's not letting me play it, but okay. So there's Asteroid 3, is 25 kilometers across. I actually tested this out. Either it's like sometime this week. I actually tested this out, and you're not gonna believe the change in impact that the 25-kilometer asteroid does once it, of course, collides with Earth. And it's so far away. There it is. Actually, asteroid 3. My bad. But it is 25 kilometers in radius, not mass. Radius. We're just gonna slow this down before it actually hits Earth. And after this, we're gonna have some fun with these. There it is. It's gonna hit the ocean. This is that earlier. It's gonna be different. Okay, guys, you ready? You ready? It's going. Dun, 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 dun. Boom! And look at that. Well, at least for, yeah, I did something. I think this did something else last time I did this. Also, the temperature didn't change, huh? I thought at this point I did something different, but I guess not. And there's not really a lot of craters because the Pacific Ocean is deeper, but there's a hole there. Alright, well, I guess I didn't do what I expected it to do. But now we're going to get fun with this. We're going to get really fun. Because now we're going to shoot it in Antarctica. Or at least there. Now this one is going to be really fun. Now guess what? This is going to be 100 kilometers. And it's actually big enough so it's like it has a spherical shape. Yeah. But this one's going to be 100 kilometers across. Yeah. So this will definitely do something to Earth. I would think so. Now again, it's making it cover than Antarctica, so we just don't have the same places being hit all the time, because that's not fair. It's for the other places that don't get hit. Slow that down, because I still have trouble scrolling with this mouse sometimes. So I gotta slow this down, and it's gonna go boom. Boom! Boom! Now you can see Earth's temperature immediately rises to 331 degrees. Like, is that crazy or what? Look at that shockwave. Oh my god. That is a big shockwave. See, Earth's temperature just went from whatever it was before, and then there's a lot more fragments too, but Earth's temperature, like, immediately rose to 331 degrees Celsius. Is that crazy or what? Now, this is just under 2 minutes per second. And all the ice is immediately gone. The water should be evaporating now. Well, of course, Earth immediately starts cooling down, and as you can see, that is happening. Now the water is going, and that's still happening to Earth. It's like ejecting particles or something. Now our atmosphere is gone, our water is gone. Again, it's not hot enough to start melting Earth, but as you can see, this would probably kill all life. This would kill all life on Earth. And they're just going to speed up time so it gets back to normal. And as you can see, the temperature is dropping very sharply. And there's some water. It's just going to be back to where it was before soon. And although its orbit might have changed a bit, though, it seems warmer than what it was before. Still. Well, let's go to the before. Now let's see the crater near Antarctica. I don't even see it. Alright, so the last collision we're going to do is, this one might be a bit shorter, but the last collision is going to be really fun. Do you know why it's going to be fun? You'll see in a second. Let's actually aim towards the northern side. This is the last one. It's asteroid finale. Guess what this is? 1,000 kilometers. That's right. 1,000 kilometers. Excuse me. Now, one time I launched an asteroid into Earth, and Earth's continents were like flooded, and that's because the asteroid had a lot of water in it. So if we do this again in another video, and then Earth's continents like get flooded, that's why, because it adds more water. This one doesn't though. Now this is 1,000 kilometers right now. Remember, we aimed, well, I tried to aim more for the top, so yeah, this is 1,000 kilometers. Ready? Boom! Look at that. It's actually cooler than what the last one did. It's actually much cooler. It's not right at all. Look at all those shock waves though. Oh my god. I'm surprised that the temperature is cooler than what the last one did. Of course, it's gonna happen again. Another mass extinction, and then the water comes back. The water comes back. Well, this video is too short, isn't it? This is way too short. So what I thought we'd do to finish off the collisions, this video is gonna be shorter than the others. I apologize for that, but now the last collision we're gonna do is, guess what? Venus. Now if I hit it this way, Earth is gonna kind of go tilt above, but it doesn't matter. Everything's gonna die on it for the third time. So let's just start launching it now. Earth and Venus might have some tidal effects right before they collide, actually. So launch is at 10 kilometers a second. I'm sure it's increasing as it gets closer. Now this is to finish off our collisions with Venus, and we're ready. Boom! Look at that. That was amazing. It actually gained a lot of mass from that too. As you can see, Earth's rotation is sort of like Uranus's rotation. It's like up and down. It's not healthy. Oh my. Whoa. Oh no. Oh no. Oh. What? Okay, so Earth. Let's look at its orbit now. Let's look at its orbit. Oh my God. Earth gets closer to the sun than Mercury does, then goes back out to where it was before. That's crazy. That's what happens in first class with Venus. That's what happens to Earth's rotation. Oh, Earth and Mercury could have had a collision there. This video is kind of too short, don't you guys think? Alright, now that's it. Well, that was the finish of Earth's collisions. Now we're gonna launch Jupiter at the sun, because something interesting happens. Alright? Now this is gonna be the real finale. Because this video is too short, in my opinion. It's still kind of too short. Let's slow this down, because it's gonna be too fast going days per second. Let's go 24 minutes per second. Now I'm sure, as you can expect, Jupiter is going to get completely obliterated. But I noticed that something interesting happens to the sun, and Jupiter should not be cooling down right now. It should be getting increasingly hotter. This is not right. Jupiter should be getting increasingly hotter. Okay, slow that down. Oh my God. Too fast still. It's speeding up. Look at that. Its speed and temperature is increasing like very rapidly. So slow that down, because I want you guys to see the effect take place. Its temperature is increasing, but its velocity is so fast. Now Jupiter's melting in the final minutes or seconds. Oh my God, it's as hot as the sun now. Like literally, its motion is so fast. Now you'll start to see something weird happening to the sun. I think this temperature changes a lot. So surface temperature. Now the sun is basically, this is what happens to the sun. What? What? Wait, what? Oh, I glitched there for a second. Whoa. So that's what happens when Jupiter collides with the sun. The sun becomes a blue star, and it's bigger, and now things are starting to go wrong. How is Earth's orbit going to be now? I don't think life can even survive on this planet anymore. How does this orbit even work now? Oh my God. Oh, it's going out. Well, Earth is still in orbit. Oh my God, it froze up. Did you see that? Oh my God. So Earth goes through a constant cycle of freezing then unfreezing. That's weird. So it like freezes, and then it unfreezes, and then it gets really hot. It gets super hot, and then once it goes around again, it starts freezing up. That's weird. Well, anyways, I hope you guys enjoyed today's video of Universe Sandbox 2. If you did enjoy it, please leave a like. If you want to see the other video I did today, it's the Roblox Center System in a nutshell. You can go see that if you want. Have a great day, and I will see you all on the flip side.